The first question that we need to ask ourselves is, what do I need to do to be able to read the user input? Well, first we need to ask him a question, right? For example, what is your name, or some question which requires the user input. So in here, instead of hello world, I want to say what is your name and print it on the screen. Also, I want the user to be able to answer on the same line and not to go to the next line. So in here I remove the 0xa, and well, the read input, which is the copy of the hello world, now the first section of it is completed, since the first 5 lines in here would print the what is your name on the screen. After that, we would want to read the user input. So first we need to know the system call related to read, which is actually with the same name. So in here I press Ctrl Shift and T and go to the I want to find the unistd underline 64.h, which is this file, and we were working with it in the previous lecture. So I copy it and paste it in here, and if you look, these are all the system calls which we were working with in the previous lectures. The right system call had the number of 1, as you saw in here. We were passing it to the RX register to invoke it, and the read system call has the number of 0. So what we need to do is to say move RAX and 0, and at the end we say syscall. When we say syscall and we pass the control to the kernel, it would look at the RX register. It sees the number is equal to 0, so it knows that it should invoke the read system call. But the read system call needs some argument to work with, some argument that we want to give it to say where do we want to save the data, or how do we want to store the data that we are reading from the user. In order for us to know these just arguments, we work with the manual page of the read. So I press Ctrl Shift and T in here and go for the manual page for the read system call. Now if you look in the description, it says read attempts to read up to count bytes from file descriptor fd into the buffer starting at buff. So this is the read system call, which it takes 3 arguments. The first one is the file descriptor which we want to read from. The third one is the number of bytes which we want to read, and the second is the starting address of where we want to save the data or store the data that we are reading from the user. Now in here you might ask a question that, well, we want to read the data from a file, right? Now how is it that we haven't opened the file? Well, it's the same question that we were asking ourselves about the write system call also, because if you want to work with a file and get a file descriptor, we first need to open that file, right? Well, the thing is that, as we said before, when we start a process, 3 files would be opened for that process, and 3 file descriptor as the handlers to those files would be passed to us, would be passed to the process, so that the process could work with those files. Those files are a standard input, a standard output, and a standard error, which all of them have the file descriptor of 0, 1, and 2 respectively. In the write system call, we were going to save or write to the standard output, which had the file descriptor of 1. For the read system call, we want to read from the standard input from the keyboard of the user, so the number of standard input is 0. So in here you pass the first argument. And also I don't remember where I should pass the arguments or which register. I just look at in here, and if you look, this would be the first argument to be passed to the system call. This is the second one, this is the third one, and I showed you a couple of other registers for the next arguments in the previous lecture. So in here I just say move RDI, and I want to pass the number of 0, which would be a standard input, and now the file descriptor has been passed, and the first argument has been just created for the read system call. The next one would be the starting address, because when we are getting the user input and he's typing something, we would want to store those values somewhere. Now you might want to save them in, I don't know, BSS section. You might want to save them in some place in memory, which is what we are going to do in here, because this is what we have learned so far. So we want to store the user input in some place in memory, right? So in here I just say let's name it mgh input, for example, and I want to define some bytes. The bytes I want to be 0x00, just some null bytes in here. Let's be, for example, 6 bytes. I think it would be enough, or maybe just 8 bytes in here, 8 bytes of null. We could just define some string in here and then override them, the same thing that we are doing in here, but I don't want to have any data or any string. I just want to print the user input. So I have defined 8 bytes of null bytes in here, and then we want to save this data, save the data that the user is entering, and override this data in here. So in here we pass the second argument by saying move, which would be RSI, and then I say mgh input, which is the label that we created in here. It's the starting address of this byte in here. So we are saying the read, we are telling the read system call that I want you to save everything that you are reading from the standard input to this memory address in here. After that we get to the third one, which is actually the size of the data that we are reading from the user, which I want it to be 8 bytes. So in here I just say move the last register in here would be RDX, and I want it to be just 8 bytes in here. So right now we would be able to read from the user, and then after that we would want to just print it on the screen, right? So in here again we would want to just copy this right in here. So I just copy paste these lines again, but instead of saying what is your name again, I want to say something else. Let's say, for example, I want to define another thing. Let's say another label. Well, thank you label, I guess, and we say db, and in here, or no, let us actually just echo the password that the user is entering in here by just saying the mgh input. So I just want to say, instead of mgh hello, I want to say mgh input. Again, the reason that I'm choosing this name, I want you to pay attention to the content rather than the name to be descriptive itself. So in here mgh input is what the user is entering, right? So in here I say the mgh input, and the mgh size I want it to be of 8 bytes in here. So whatever the user is entering, I want the write system call to be invoked and print it on the screen. So in here I press Ctrl O and hit enter to save it and exit. Now we would want to just assemble it. And now we execute our program in here. We hit enter. What is your name? Let's say mgh, hit enter, and we have the password or name just printed in here. We could just say another thing, just say Brad, and hit enter, and we have the name in here. So we were able to get the name of the user or get the user input and print it on the screen.